In this video, we're going to calculate the antiderivative of the tangent of x. And after we find this, we'll have this antiderivative in our back pocket. So in order to do this indefinite integral, we're going to use the quotient trig identity tangent of x is equal to sine of x divided by the cosine of x. So we rewrite our integral as the integral of sine of x over cosine of x dx. And then what we're going to do is we're going to use u substitution. So we're going to let u be equal to cosine of x. We're going to differentiate both sides, so du dx is equal to negative sine x. And then we're going to solve for dx. So when we solve for dx, we're going to get dx is equal to negative 1 over sine x du. Now we're going to make our substitution. So we'll have the integral. I write the sine x here in the hope that it's going to cancel out. My cosine of u is my u, so I put a u there. I replace my dx with the negative 1 over sine x. Maybe I'll put that in parentheses, du like this. And what do we see? We see that the sine x in the numerator and the sine x in the denominator cancel out. And we could take this negative 1 and we could factor that out of our integral completely. So our integral is going to become negative the integral of 1 over u du. Now, as we've seen before, the antiderivative of 1 over u is just going to be natural log of the absolute value of u plus c. Okay, so we can't leave our answer in terms of u. We need to switch it to be in terms of x. So this is going to give us negative natural log absolute value of cosine of x plus c. We can use our third law of logarithms to move this negative back up as an exponent over here. So when we do that, we're going to get natural log of the absolute value of cosine of x to the negative 1 power plus c. And now we're going to use the reciprocal trig identity. We know that the reciprocal of cosine of x is going to be secant of x. So the final answer we'll get is natural log absolute value of secant of x plus c. And that's how we find the antiderivative of tangent of x. So now we can just use this as our antiderivative. All right, everybody, take care.